Hey everyone, welcome back to my channel EduVibe. Today we will doing the forces and fields and we are doing the diploma question of the whole unit. So this is grade 12 physics and today we are completing the forces and fields with the diploma questions. So let's start with diploma questions and first diploma question is here. So says that the glass rod is dropped with silk and the glass rod gains a positive charge. So basically that glass rod up with the silk and the glass rod gets a positive charge and the charged glass rod is then brought near the neutral pieces of the paper and it attracts them which of the following rules is true. So what will happen that some positive, so we have a positive glass like this over there for example, and this they have electron and the silk get the negative charge. So the silk has a negative charge on it, and when it goes to papers and we that attract the neutral particles, they attract those. So method charging the glass rod. What is the method? So we are rubbing. So this means this is the friction. So this is friction, and material that is higher on the electrolyte series is which one? Which is higher on the electrolyte series, which is silk. So glass is like on the board, after the silk, because with the higher one is the silk. Because silk has the more capacity to that attract with those positively charged things. So this means which is the option for this? The A option. So this is the A option for this. So next question says that the electric force between the two charges F, one of the charges then tripled, and the distance between them is quartered. The new electric force between the charges is what. So basically we have to know first that what is electric field is equal to. So we done this before because electric force is equal to K Q1 Q2 upon R scale. So that's the formula and they tell us that the two charges, electric force between the two charges, one of charges tripled. So one of the charges tripled. So if the Q1 is tripled, so like this. So and the distance between them is quartered, so q2 stays the same and that is quartered like this. So if it's quartered and you have to find that fe, what is equal to, so this is k 3k q1 q2 divided by 1 by 16 r square. So when we do like that or quotient, this all goes to 1 and that all goes to 1 and then we get the 3 divided by 1 upon 16 r square, which goes to something when we this goes to multiply, this 16 goes over there like 3 and we get 48 and this is f. So this 48 times f. So that's our thing when we that know any number, this again this all things goes to 1. This all goes to 1. This all goes to constant. The things we have, that we have a triple, we have quarter, that's the thing we will have to mention over there. But the other things goes to 1. And when we do the multiplication, when we do reciprocal of this, we get 48f. Because there's a new one we have to find, so we have to write the 48f. Next one. So in this, the 2-point charges are arranged on a line. So we have two charges arranged on a line and this has the P point. Measure of the net electric field at P expressed in a scientific notation in this, and so this which well. So we have to find the net electric field, which is like E1 and E2, and we have to plus them. So firstly, we have to find E1. So that's the simple thing that is positive. So this is positive, and this one is positive. This one is negative. So not depend like on this. We just doing the E1 and E2, then we have to plus them to find the net electric field at P. So for E1, let's do, so for this we use that this formula which is E1 is equal to KQ1 R square, this one. So for the first one, so this is the first one, so this is first one, this is second one, and we use that formula because this is like the point charge formula we use when we use the test charge and point source charge. So that's the formula we use. So for E1, K is 8.99 to 10 raised to power 9 Newton meter square C square. Q1 is this 1.0 into 10 raised to power minus 16 coulombs, which is a microcoulombs value, and this is 2.0 meters, so it stays in meters. This is clear out. So E1 is equal to 2247.5 Newton coulombs. For E2, we do the same thing. KQ1 upon R square 2. So this is 2 now. So E2, 8.9 into 10 is 2.9 Newton meter square upon C square. And we're not losing like minus 9 in this, as you all know that. We're just 4.0 minus 6 coulombs. And this whole divided by the 1.4 meter square. So when you find this, you get E2 about 3110.73 Newton coulombs. So that's the two things we have to find. And now we want to find the net electric field. So for the net one, just do E1 plus E2. So for net one, so basically there is a one thing in this now. So we want to know the directions of this. So if like this is positive and this is also positive, so this goes away from it. So like this, if we need of a positive, and if we compare with this, so it goes like away from this, and this negative, and this is positive, so it towards this. So for the free body diagram like this, if you want for free body diagram, so this is your P point. If this is your P point, so this is your F2 and this is your F3, or you can say E3 or F3, or you can say this one. So the tension 1, this is tension 2. So that's the thing. So we take one side positive, another side should be negative. So in that case, I take E1 as negative. So that thing I take negative. So left one is needs to be negative because I take this one positive. So this one is negative. So when we're doing this, so E1 is negative 2247.5 Newton coulombs plus E2 is 331.073 Newton coulombs. So the net force, net electric field is equal to 8.6 into 10 raised to power 2 Newton coulombs. You will get this answer like in 863, but we want in a scientific notation, so we converted this into this. But if we are in written, so that's the answer. But we want in like this form. So in numeric, we have to write this one. So your numbers are 8, 6, 2, 6, and 2. So that's how you can find your electric field, net electric field. Let's move on to the next question. Next question says that which row identifies the direction of the north and of the compass needles for both the capacitor on the bar magnet. So we have the compass, this over there, this one and this one, and that bar magnet we have to find the direction of both, and we have to find which option is best suited for that. So firstly, we have the north pole over there. So north pole of the capacitor points in the direction of the magnetic field. So where's the direction of the magnetic field goes? So in that type of thing, the magnetic field originates from the north and goes over there. So they follow that direction. So this means magnetic field is over this direction. So magnetic field goes this direction because we mentioned already over there the north pole gives you the magnetic field direction. And for this one, if they goes under this and this also doing from here and goes over there, so again the magnetic field goes like this. So this means that this direction, the magnetic field goes from north and enters to the south. So they goes this direction. So this means this goes the right. So this is your right direction and this is your left direction. So this right and this left are B option. So for this you will get B option. So always remember that north pole will give you the magnetic field direction. For north pole, where's the north pole? National magnetic field follow that thing. So that's the thing because we have that thing in our mind. So that's the answer for this. B part. For the next one, the current carrying wire is placed between the two magnets that is perpendicular to the magnetic field as shown. So we have a diagram over there, but I think they didn't give us diagram because So the wire has the weight of 0.50 newtons and we have a length of 0.0700 meters within the magnetic field. It then receives through a current to suspend the wire between the two magnets. If the magnetic field strength between this is 1.10 Tesla, then the current required to suspend the wire is what? So basically, we have to find the current in this. So for the current relation, we have the magnetic field over there, involve the magnetic field in this, and involve the gravitation force, because magnetic field and the gravitation force all both are perpendicular. And for the current carrying wire, we know this is the relationship we have to use, which is Fg is equal to the Fm. So we know that Fg is like this goes Fm, and this is your Fg. Free body diagram we have. So that Fg is directly given to us, which is 0.500. This is the wired weight. So it's Fg is always equal to this, because this is time of the in newtons, and this is also the Fg we have given to us. So Fg is given to us, and we know that Fm is equal to IL magnetic field. So I is equal to Fg divided by L magnetic field. So the I is equal to 0.500 newtons divided by the length is 0.0700 meters, and this magnetic field is equal to 1.10 Tesla. For the trend, when you solve this and multiply this, we got about 6.49 ampere. We got increases this, so this is your answer. So why I choose that question as small question with the long much like not like long calculations, because there's a thing that sometimes you have also given the Fg involved in this. Not every time we have to find that. We have sometimes this, and we have to keep in mind this is the electron. Like this is in the Newton value. So if you're talking about the weight of the wire in any question of the current carrying wire, so that thing sometimes given to us. So that small calculation like thing you will get. So that's the tricky part in that question that you have to know now. So there's a thing they're calling about the suspend or the suspend. We don't like worry about this, because we don't need any net force involved in this. We just need Fg is equal to Fm. But we have to know that suspended means net force is equal to 0. For the next one, this is a written response question from the diploma, and we have to know that how can we deal with either long questions, and sometimes they also have the long answers too. So let's deal with that question. The question says the charged particle that has mass of 2.8 10 to the minus 16 kg accelerates upward 3.0 meter per second steer in the electric field between the two horizontal plates, and their suspension of 0.10 meter. The potential difference across the plates is 400 volt. The experiment from the Earth's surface at the sea level. Resume no air resistance is there. So for the above configuration, determine the magnitude and the direction of the electric force on the particle. Notify the charge, and then we have some one theory question. So that's the type of thing you also that sometimes in the written you get some theory question to answer in like some sentences you have to answer. So first question only involves we have to find the electric force, their direction and the magnitude. So how can we do this? So you know that F net is equal to Fe plus Fg. You know that. We want that thing. So Fe is equal to F net minus Fg. Fe is equal to Ma minus mass into gravitation. So this is where I make a common acceleration minus gravitation. So what is mass? So mass is given to us, which is 2.8 into 10 raised to a minus 16 kgs. What is acceleration? Acceleration is also given to us, which is 3.6 meter per second square minus. So gravitation force in that case also takes it in negative. Why is it negative? Because you will see that the when we made the free body diagram of this, your Fg goes down because this shows that this thing goes upward, which is your electric field. So your electric field goes up, so Fe goes down. That Fg when it goes down, so we take upward as positive now because we find in the Fe, so Fe should be in positive. So this means the gravitation force should be in negative in that case. So that's why we take this in negative. So Fe, what do we get? We get something 3.7548 into 10 raised to power minus 15 newtons. And also when you that inside this, we get into this, so 3.8 in 10 raised to power minus 15 newton. And this goes upwards. Dash. So this is for your first part, this one. For second part, we have to determine the charge. So charge is very easy to find now because we have Fe now. So Fe is equal to what? Q times electric field. But we don't have electric field directly, we don't have electric field. But we have delta V and delta D. We have delta V, we have delta D. So from that two things we find the electric field and then multiply this by the charge. And the charge we have to find, so then we have to have the electric force, so then we get to find. So simple thing, we do electric field is equal to Q times delta V upon delta D, which is equal to electric field. And yet Q is equal to Fe, this times delta D upon delta V. So Fe we already find 3 from the non-valued value. 7.78 is equal to 10 raised to minus 15 newtons. Delta D should be in centimeters, so it's 1.10 meters. Divided by delta D, which is 400 volts. So what is Q? So when you find, you get Q of 9.4 in 10 raised to power minus 19 coulombs. Now, this charge, where they go? Where the charge goes? So this charge goes, this charge we get in positive, but they attracted to the positive plate. Q is positive plate. So over there, this plate is positive. This plate is positive in that case. And this plate is negative. So this goes to the positive plate, but if the charge is in positive, so there's no thing like why they goes to positive. To positive didn't like do anything. We have to do the attraction of something. So we have to do this charge in negative now. So the answer should be negative in that case. The charge we take in negative in that case because the positive negative do attraction, positive do the repulsion. So there's a wrong one. So that's why you do this. So it's a wrong, try to do a conservation of charge. That's how we want to be this in negative 9.4 in 10 raised to minus 19 coulombs because it tracks into a positive plate and Q should be negative. So that's the thing we have to do. So the last thing, which is a new thing for you because the written you not normally like the written in that of thing. So as they mentioned, assume now that the particle is initially at rest. So they mentioned that the particle, this one is initially at rest between the plates. If the charge on the plates were inverted, we inverted the charges. What we do, we inverted the charges, negative plate becomes positive plate, the negative becomes positive, the positive becomes negative. So this they tell us. Compare the resulting acceleration with the acceleration above. Export your answer with the theory of the physics, no need for calculation. So we didn't want any calculation involved in this. We just see that what will happen. So if we flip the plates, so what will happen? The electricity force will be downwards now. So flip the plates will affect what? So flip the plates will affect that Fe goes down now. And sometimes it means that Fe plus Fg will be the same direction. So the Fe also goes down because Fg always goes down. Fe can change their directions, but Fg didn't change their direction anymore because that upward is against the gravity. Fe goes down because of the charge interchanging, and Fe also goes down. So that part you have to know, that part you have to mention in your answer when you write the things. So the acceleration will be greater than the 9.81 meter per second square, because when FG and FE goes all both are in the same direction, so they no more than 9.81 meter per second square. They should be greater than those. Greater. So therefore the acceleration will be increased in that case. So we have to find the acceleration of the increase. So basically what happened when we change the things, what will happen that FE goes downwards. If it goes downwards, so this will happen the same direction, both are in the same direction now, FE and FG. This will greater our acceleration greater than the 9.8 meter per second square. So therefore, because of that reason, what will happen in the mean one, that acceleration will increase. So that's the 3 points you have to mention. And if you want, you can make that type of diagram if you want. But that thing should be mentioned in your points, that all 3 points should be mentioned, that why this happened. And for this, the main reason for the happening is that the acceleration will increase. So that all thing we have to do with our physics knowledge. They mentioned that over there. With the theory of physics, you have to know, not with any calculation. We just doing the, like, we have to just do our theoretical knowledge. We have to rewind that all concepts and that to the answer of that written response of this. That's 10,000 commonly got sometimes, but then if you don't know, so it's well and good, but you have to know this. So that's the whole thing you have to do in that type of returns, and that's all the diploma questions we discussed now. So we officially completed a unit. So unit is completed now, and so now we will start with another unit, but after that few days. So not by like tomorrow we'll start the next unit. Next unit is electromagnetic radiations, which is like not very big unit, but they have so many topics to cover in this, so many concepts to be know in that unit. So we will done the 2 units. Now we'll move on to the next 2 units. Firstly, the unit C. So let me simplify. I do vibe, learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay with Edu Vibe.